Greetings, cosmic voyagers. Today we're diving into an astronomical enigma that has baffled scientists worldwide. Imagine looking deep into the cosmos and finding 12 apparently identical galaxies, mirror images scattered across the sky. This isn't science fiction, it's a genuine puzzle emerging from the depths of space, challenging our understanding of galaxy formation and the fundamental laws that govern our universe. Join me as we embark on an investigative journey to unravel this extraordinary phenomenon. When we speak of identical galaxies, what exactly do we mean? Galaxies exhibit a stunning diversity of shapes, sizes, colors, and compositions. The notion of finding even two galaxies that are perfect doppelgangers would be astronomically unlikely. Now imagine astronomers cataloging the deep sky and stumbling upon 12 such celestial twins. This is the core of the phenomenon we're discussing today. Discoveries of this magnitude rarely happen by grand design. They are born from serendipity. Let's imagine this revelation began with the Cosmic Cartographer's Survey, utilizing the Arachne array of telescopes. Dr. Evelyn Hayes and her team at the Interstellar Mapping Institute were processing data when an anomaly detection algorithm flagged a peculiar pattern. Initially, they suspected an instrumental artifact. After exhausting all possibilities of errors, they began to entertain the idea that the observation was real. The excitement would have been palpable, yet tinged with caution. The team would have re-observed the field multiple times, ensuring the objects persisted and their characteristics remained consistent. The burden of proof for such an extraordinary claim is extraordinarily high. Picture the scene late nights in the observatory, fueled by coffee and the thrill of potential discovery. The moment when Dr. Hayes finally turned to her team and said, "I think this is real, we have something incredible here." The significance of discovering 12 identical galaxies cannot be overstated. If these were truly distinct galaxies, it would shatter our understanding of galaxy formation. The far more plausible interpretation points towards strong gravitational lensing. We are not seeing 12 different galaxies, but 12 images of the same distant galaxy. Its light bent and multiplied by a massive intervening object. Finding a system that produces 12 distinct images is exceptionally rare. It would imply a highly structured and massive lensing object, providing an unprecedented laboratory for studying the distribution of mass within that lens. Confirming that 12 celestial objects are identical is a monumental task. The first step involves detailed imaging across multiple wavelengths. Astronomers would meticulously compare the morphology of each of the 12 candidates. The gold standard for confirming the nature of these objects lies in spectroscopy. By splitting the light from each galaxy, astronomers can measure the redshift and chemical composition. If these are multiple images of the same object, their redshifts should be identical. This is an incredibly data-intensive process requiring many hours of observation time. Only after exhaustive, multifaceted analysis with results cross-validated and peer-reviewed could the scientific community confidently declare these 12 objects as truly remarkable manifestations of a single lensed source. When faced with 12 identical galaxies, science seeks explanations rooted in known physical laws. The most compelling phenomenon capable of producing multiple images is strong gravitational lensing. Mass warps the fabric of space-time, bending light from a distant source. For 12 distinct images to form, the lensing system would have to be exceptionally complex and massive. It likely involves a rich galaxy cluster with a specific distribution of mass, including dark matter. Astronomers would use the observed positions and properties of the 12 images to reconstruct the mass distribution of the foreground lens. The fact that there are 12 images provides a wealth of information, potentially allowing for a detailed map of the dark matter within the lensing cluster. Let's delve deeper into gravitational lensing, the prime suspect behind our mystery. Einstein's general theory of relativity taught us that mass warps space-time, bending light. Strong gravitational lensing occurs when the alignment between the source, the lens, and the observer is precise. This can create multiple images of the background source. To produce 12 distinct images, the lensing system must be extraordinarily complex. It's likely a massive galaxy cluster with a lumpy distribution of mass. These 12 images act as natural telescopes, magnifying the distant source galaxy. The discovery of 12 lensed images carries profound implications. It provides an unparalleled opportunity to map the distribution of dark matter in the lensing galaxy cluster. The magnification effect of the lens is a boon for studying the distant universe. The lensed galaxy can be studied in detail, providing insights into galaxy evolution in the early universe. If the lensed source exhibits variability, the time delays between the images can be measured. These time delays offer a powerful way to measure cosmological parameters like the Hubble constant. This discovery could spawn dozens of research projects, engaging astronomers across various specializations. While gravitational lensing stands as the most robust explanation, we must acknowledge alternative ideas. Could there be an unknown mechanism of galaxy formation producing identical galaxies? This is highly improbable. What about exotic cosmological scenarios like a multiverse? This remains far from empirical science. Scientists adhere to Occam's razor. The simplest explanation is usually the best. Another alternative might be multiple, perfectly aligned lensing events. Ultimately, the gravitational lensing explanation is consistent with existing evidence. When a discovery like this emerges, the astronomical community buzzes with discussion. Leading scientists offer their perspectives, grounding the excitement in rigorous analysis. Professor Anya Sharma might comment, "This observation is a goldmine for mapping dark matter distribution." Dr. Kenji Tanaka could express awe at the observational opportunities. It's like being handed 12 windows into the early universe. Theoretical astrophysicist Dr. Isabella Rossi might say, "Modeling such a lens is a beautiful puzzle, a gift from the universe." This collective investigation drives our understanding forward, transforming a baffling anomaly into a powerful probe of the cosmos. A discovery of this magnitude signals a vibrant beginning for future research. The immediate next step is securing more detailed observations across the electromagnetic spectrum. The James Webb Space Telescope would be crucial for dissecting the light from these lensed images. Spectroscopic follow-up would allow for precise measurements of redshift, chemical abundances, and internal kinematics. A significant effort would be dedicated to characterizing the lensing object, the massive galaxy cluster responsible for this cosmic mirage. This discovery could spawn dozens of individual research projects, engaging astronomers across various specializations. Following such a landmark discovery, the global astronomical community would mobilize. Large-scale sky surveys would be revisited, and projects like the Vera C. Rubin Observatory's Legacy Survey of Space and Time would be ideal for finding similar lensing systems. Space telescopes like Euclid and NASA's Nancy Grace Roman Space Telescope would play a vital role in mapping cosmic structures. Computational astrophysics would see a surge in activity, with teams attempting to create numerical models to reproduce the lensing configuration. International collaborations would form, pooling expertise and resources. Citizen science projects could also play a role in identifying unusual lensing features. This discovery will undoubtedly spur efforts to develop new algorithms and survey strategies. The search is on, and this discovery will engage astronomers worldwide in unlocking the secrets of this extraordinary cosmic alignment. Even as gravitational lensing emerges as the most compelling explanation, a profound sense of mystery endures. The mystery shifts to what precise configuration of mass could create such a perfect cosmic mirage. The enduring mystery lies in the details of this cosmic lens. Is it a single exceptionally massive galaxy cluster or a chance alignment of multiple clusters? This system could become a benchmark for understanding dark matter and cosmic structure. The 12 identical galaxies remind us that the universe is constantly challenging our understanding, offering natural experiments of incredible scale and beauty. Thanks for joining us on this cosmic journey. We've explored the phenomenon of 12 identical galaxies, a discovery that stretches our imagination and scientific toolkit. The quest to fully understand this system is far from over. It will involve ongoing research, new technologies, and the collaborative efforts of scientists worldwide. Don't forget to like, subscribe, and hit the bell icon for more astronomical mysteries. Until next time, keep looking up. The cosmos awaits, full of mysteries yet to be unveiled.